So this PowerPoint is on periodic functions, and it is the last function you will have to learn this year. A periodic function could look like this, where you have waves, or it could look something like this, where it's really piece by piece, but still the same kind of pattern. There are actually a lot of components to periodic functions, but we are just going to focus on two. The first one that we're going to look on is the cycles and periods of a periodic function. The second one is the frequency of a periodic function. So you'll be introduced to these in just a few slides. First, though, I'm going to give you a fancy definition from your visions book. A function is said to be periodic when its graphical representation consists of a regularly recurring pattern. So the key word here is a pattern. The interval between the x values located at the extremities of this recurring pattern is the period of this function. So when you find the period, it's when the pattern starts and ends. Another fancy definition from your worksheet package says a function f is considered periodic if there exists a real number a such that for every x of the domain f, we have f of x plus a is equal to f of x. The smallest value of a, for which f of x plus a is equal to f of x, is called the period of the function. And we call the period just a big P. This basically tells us that a is the period of the function, and every cycle goes by a plus a plus a plus a plus a. And I'll talk about that in a second. I'm sure you're wondering what this means. Let me show you. Here's our periodic function. I'm going to try to find where it begins and where the pattern ends. So I'm going to just put a line right here. So I'm saying that it's going to start here at this line. Where does it end? Well, it goes down, up to here. So it must stop there. And then again, down, up, and then down, up to there, and then we start again. And then again, down and up. So I'm going to denote every place that we put this, and we're going to call this x1, x2, and x3. So here it hits, goes up. Here it hits again, goes up, goes down, and then here again. If you notice, this here is the pattern, and then it starts again, and then it starts again. This pattern is called a cycle. So I start here, I continue, and I start again. Where I start again, this is called a cycle. So if I take that same graph and I tell you that this here is a cycle, and I ask you to find the period is basically how long is the cycle, and we're only looking at our x values. So in this case, our first x is negative 2.1, our second one is at 2.1, and our third one is at 6.3. The period is just the difference between these 2 points, any 2 points. So from the start to the end, or from the start to the end. So pick a start and pick an end and subtract them. If we were to pick the negative 2.1 and 2.1, we would have 2.1 minus negative 2.1 is equal to 4.2. If we were to take the cycle between 6.3 and 2.1, we would get the same value of the period. Therefore, the period of this function is 4.2. When you get approximately the same number for each cycle, that's when you know you have a periodic function. Please note that it doesn't matter where you start or end your cycle. So for example, we started in the last slide on the x-axis. But we don't have to start there. We could do from hump to hump, so from here to here. And I can promise you that if we were to subtract this minus this, we would get the same period. So here's 5.1, here's at 0.9 on the x-axis. If we were to subtract them, sure enough, we get 4.2, which is what we found the last time. So just remember that it really doesn't matter where it is that you want to find the beginning and ending of your cycle. So you can do it up here. You could have even done it from the bottom humps from here to here. So you could think of it as like doing it from peak to peak if it helps you more. The frequency. The frequency of a function is in the name itself. It's how frequent a cycle occurs. How often on a certain period of time does this cycle occur? The logistics of this depends on the reason for the graph. So is the graph for time? Is it for cost? For example, is it how often your heart beats? So then you could find how many cycles of a heartbeat there is in, say, an hour, or so on. To calculate the frequency of a function, you just have to do 1 divided by the period, or 1 over p. That's how we find the frequency of a function. In our example, the period was 4.2. So the frequency is 1 over the period, so we would have 1 over 4.2, and if I round it, it is approximately 0.24. It is better in this case to actually put it in as a decimal and not leave it as a fraction, because that way we know that there are 0.24 cycles in a certain amount of time. If we put this all together, our cycle and our period and frequency, and the word problem that we're working on has x to represent time, for example, the period is just how long is one cycle from the beginning to the end. That's how we subtract it, how long one cycle lasts. The frequency represents the number of cycles in a period of time. For example, 2 cycles per minute, 500 cycles per second, etc. And remember, we find this by just doing 1 over p. So try this one yourself. Looking at this function, find the period, the frequency, the domain, and the range. In this case, if we were to pick either from peak to peak, from bottom peak to bottom peak, or from x to x, you would find that the period is approximately 3.2. Could be 3.1, could be 3.15, but I'm going to say that it's 3.2. The frequency is 1 divided by the period, so it would be 1 divided by 3.2, and that's 3.1. The domain is all real x values, so all r, it goes over all r, all x values are being used for this function, and the range is from bottom to top, -4 to 4, so it's -4, comma, 4, close bracket. Here is a different kind of function, but it is a periodic function, but instead of using curves, we are using big peaks. These kind of look like little mountains. So find the frequency, the period, the domain, and the range of this function. In this case, if we were to do from peak to peak, we could use, this is -2 and this is 1. We could use 1 minus -2 and we get a period of 3. If we want to find the frequency, we do 1 over the period, so it's 1 divided by 3, which is approximately 0.33. The domain is still all x values. Imagine that this goes off the chart, so it goes on forever, so it's all real x values. And the range from bottom to top is -2 to +4, so it will be -2, comma 4, close brackets. Types of problems with dealing with periodic functions, it will be more common for you just to analyze the graph than to answer word problems that go with it, luckily. You still need to recognize when to use a periodic function, so you still need to know what kind of word problems deal with periodic functions. These types of word problems and periodic functions are usually for science. They are very scientific. Word problems that usually need to find the frequency of, say, your heartbeat, so an electrocardiogram, alternating currents, so electricity, even the phases of the moon. It goes from full to half, new, half to full, and etc. Or something like filling and emptying a water basin. A lot of these have to deal with science.